So to make best use of our time, let's get started. My name is Dan Costa. I'm a member of the, advisory staff for Clean Air Carolina and helping organizing this meeting. And I had the good fortune of chairing this particular breakout session on industrial hog farms, air pollution, respiratory disease. And we have the good fortune of having Dr. Caresse Gerald, who's an assistant professor at NC State, North Carolina Central University. Forgive me, too many North Carolina universities, I guess. But her laboratory focuses on environmental exposures, airway pollutants, and looking at issues of the respiratory impacts associated with smoke, hog farm, dust, etc. And I'm going to let her do the speaking and communicating and give us time for questions afterwards. So Dr. Gerald, if you wouldn't mind beginning.
Thank you so much, Dr. Costa. And thank you all for attending today, this breakout session. So I'm going to go ahead and jump in. Just a little bit of information or background on KFOs because they get a bad rep, but I wanted to go through and list some pros and cons of KFOs. And if you don't know what it stands for concentrated animal feed operations. So some of the pros include increased number of animals and less space. So that means, of course, you can have, you can stock your animals denser in a small amount of space. It also allows us to move food animals in and out in large quantities, which makes a huge deal when you're thinking about lower prices of food. So if you go to the grocery store, your burgers or your pork chops won't cost as much. And also, concentrated feed operations are usually going to help protect the animals against weather, parasites, predators, and so forth. Of course, there are a lot of cons to the KFOs. And some of these, of course, have been mentioned earlier in this symposium. And one of the big ones, of course, is increased waste and pollutants. So, of course, you have so many animals, which is going to lead to a lot of waste. And there are a lot of pollutants that are associated with that waste, including those hog lagoons. There are also concerns with antibiotic resistance because there are an overuse of antibiotics used in these types of operations. So a lot of times we have antibiotics that are in the feed of the animals. So the animals are exposed to the antibiotics through their feed and water, not just given by veterinarians or by farm workers. Another con to KFOs, of course, is that animals are going to lack space for movement. And this is done inadvertently in a certain type of way because of the design. So you want, of course, lots of animals in that space, but also because you want your animals to go to market faster. They're going to gain weight faster if you're allowing them to move. The meat sometimes is going to be tougher because they're building up muscle. They're going to expel calories. And so, of course, those animals are going to be usually a little bit more smaller or leaner than animals that are stocked really dense and not allowed to move around. And the one big thing, of course, that we're going to focus on today is poor air ventilation and air quality. And so, of course, it's an NC brief, so that's my focus for today, although there are, of course, a myriad of other issues and concerns with environmental quality and KFOs. So this here is just taken from the NC Department of Environmental Quality website. This is a map of North Carolina, and it shows the animal operation permits for the state. And of course, we've talked about this earlier today. You can see here on this map that there's a dense population of animal feed operations in North Carolina, but more specifically in the southeastern region of North Carolina. So there are a lot of concerns here. Also, what was mentioned before is that, of course, it's along the coast. So the top 10 hog producing counties are actually situated on the coast, which, of course, we know North Carolina is hurricane prone. So there are a lot of issues that arise when you have so many animals in a very susceptible geographical location in the state. The next slide, I just wanted to kind of give you a better perspective of how these counties and kind of what they look like as far as poultry production as well as hog production. And so these maps here show turkeys raised in North Carolina, broilers, as well as layers. And so, of course, we have poultry production for the state and how they're distributed throughout those different counties. There's a lot of overlap here, and you should notice that, of course, from the previous slide, there are a lot of course, animal operations down in southeastern North Carolina. And you see here that there are a lot of poultry operations occurring in the southeastern part of region of North Carolina as well. And there's a lot of overlap with counties such as Duplin and Sampson, as well as Wayne and Bladen County. And the next slide actually shows hogs in North Carolina. And so, of course, there are a lot of hogs being produced in that southeastern region of North Carolina as well, which makes the next kind of couple of things I'm going to talk about very interesting and kind of complex to kind of delve into. So the demographics for North Carolina are very interesting. So in a study done by Chetty et al. 2016, it was noted that there is a low life expectancy for residents of southeastern North Carolina when they observed high and low income communities. And a study by Julie Kravchenko over at Duke noticed that there are more African-American and as well as American Indian residents near KFOs in southeastern North Carolina. Some of the health outcomes or health effects included increased mortality due to infections, anemia, kidney disease, have infections twice, that's how bad it is, as well as perinatal conditions and low birth weight infant morbidities. And so they used GIS to actually look at this. And so they weren't able to link causality with some of these diseases or what we say illnesses. However, there definitely are some issues that, you know, can arise when you're thinking about how close in proximity people, especially people of color, and maybe even low socioeconomic status communities are in proximity to KFOs. So moving into more of looking at what happens as far as swine dust and respiratory health, Kelly Dunham has completed lots of papers, and he had seminal work in 1995 that actually talks about respiratory dysfunction in swine production facility workers. And he noted that there was a dose-response relationship of environmental exposures and pulmonary function. And so this was one of the first works that really kind of put some of these issues on the map as far as swine dust and being, of course, susceptible to some of these issues. This is just a list of organic dust-related airway diseases. Some of them you probably have heard of, like bronchitis and asthma, COPD, but there might be, of course, some that you have not heard of. Mucous membrane inflammation, organic dust toxic syndrome, there's pneumonitis. And so it really is a complex issue when you have a lot of patients presenting with all these different types of signs and symptoms, and then trying to tease out and figuring out which or what type of airway disease they might have. Jill Poole and Deb Romberger, they are actually MDs, and they work at UNMC, University of Nebraska Medical Center, and that's where I conducted my postdoc research. And so they were able to, you know, look at some of these things and think about, you know, how is it when it's presenting, of course, in a clinical setting. So moving along to what's in the dust, because I think it really boils down to saying, hey, we know that the dust causes these issues, but what's in the dust? And so Donham and Thielum had some seminal work that they completed that kind of talked about some of the issues or some of the different components of the dust. And I completed as a part of my doctoral research, some of the inorganic as well as organic components of the dust. And it's very complex. It depends on season. It depends on the unit and how many animals are stocked and all those different things. But for the most part, you have a lot of inorganic components like gases, like ammonia, you have pesticides, even diesel exhaust. There are certain elements that are can be found in the dust, like aluminum and silicone and phosphorus. But organic components like animal dander, feces, insects, feed particles, all of those also can be found in the dust. And here is some work that I conducted as a doctoral student looking at the particulate matter. And so we were able to characterize particulate sizes for different types of agricultural husbandry units in different in the dust samples. And so we noticed that there were inhalable and thoracic sized particles in the swine unit dust. In dairy dust, we found mostly inhalable particles. In the equine, which is mostly horses, we found inhalable and thoracic sized particles. And in the poultry dust, we found there were inhalable and thoracic sized particles. And for the most part, inhalable and thoracic sized particles are going to reside, or they're going to deposit in your nose, in your upper airway, as well as even in your tracheobronchial region of your airway. There's a huge microbial diversity of agricultural dust as well. There can be viruses, bacteria like Listeria, Salmonella, as well as fungus, different types of fungus in the dust. And so, of course, that increases the complexity of what you might find depending on the season, depending on the day, the time, how many people are in the plant, how many animals are in the plant, is it a shipping day, is it not? So all of those are different factors that can, of course, lead to different types of issues when you're thinking about dust and breathing in this dust that accumulates in these facilities. So most of my work was completed at the molecular level. And so I had the privilege of coming in after Dr. Michael McCaskill, who was a postdoc at UNMC, and he did a really interesting paper where he exposed mice to the hog-borne dust. And this was a control group, of mice. And so these mice, of course, did not receive the dust. And so you can see this is a lung slice here. These are the clear circles are alveoli sacs. They're clear. There's a lot of gas exchange that can go back and forth freely. But interestingly, when you expose these mice to dust, they had these lymphocytic aggregates. And so that's what you see here in these purple-like nodules. And the lymphocytes are basically coming in there trying to help clean out or get rid of some of these types of infections, any types of particulates, basically any foreign or xenobiotic kind of things that could be present in the lung. They're there to kind of come and save the day. And so this was a really interesting paper to see, you know, just on a clear lung level, this is what's going on in the lung when you're exposed to that hog-borne dust. In some of my work when I was a postdoc, I looked at NF-kappa B, and NF-kappa B is a major transcription factor of inflammation. And so in that study, we looked at NF-kappa B in airway cells, and we exposed the cells to this dust extract. And what we noticed is that there was an increase in NF-kappa B, which means that there's some type of inflammation going on. And we also know that NF-kappa B is an inducer of pro-inflammatory genes. So we also know that, of course, there are a cascade of events that occur on a cellular level that can now be a proponent of inflammation in the body. Some of these cytokines that we looked at as far as pro-inflammatory cytokines were TNF-alpha, IL-6, and IL-8. And we did this work in cells, and we noticed that we also have an issue because there are hog-borne dust that generates TNF-alpha release, IL-6 release, and IL-8 release, which are all pro-inflammatory cytokines. An interesting component of this is that if you look at alcohol or ethanol, and you expose or do a co-exposure, you can actually blunt the TNF-alpha release. And I won't have enough time to go into it today, but it's really interesting because we think about populations of people, socioeconomic status, and so forth. But there are farmers, there are ag workers that consume alcohol. And so that's a huge part of, you know, looking at public health and trying to figure out where the comorbidities lie and things like that. But alcohol, of course, people, when they consume alcohol, they can decrease some of their normal antioxidant reserves and, of course, be susceptible to other issues down the line. And so it's really interesting when we think about populations near southeastern North Carolina. Another issue that we see with the dust or dust exposure is reactive oxygen species. And reactive oxygen species, for the most part, are endogenous. They can be endogenous as well as exogenous. Dust has been known as an exogenous source of reactive oxygen species. Two that we looked for before or nitric oxide as well as hydrogen peroxide. Free radicals or reactive oxygen species can tear up the cell by breaking down the cell membrane. They can bind to proteins, DNA, as well as lipid, and so they can cause a lot of damage. And so this was data here that we saw an increase of dust with nitric oxide levels increasing. If you increase the dust, we also saw the hydrogen peroxide increasing. And so those are definitely some issues as well, because we know that this inflammation is occurring. And of course, there are issues on the cellular level when you have dust exposures. One other really interesting fact was that Catalase, which is a common respiratory antioxidant, so your body normally makes Catalase just normal, just at, ad libitum to make sure that it helps to protect you. There was an increase of Catalase activity with hog-borne dust exposure, which means that, of course, it goes hand in hand with the hydrogen peroxide data, because Catalase catalyzes hydrogen peroxide into oxygen and water. And so, of course, it goes hand in hand with the data I just showed you all, that, of course, there's hydrogen peroxide that is being generated. And, of course, there's Catalase activity. So you're generating more antioxidant to, of course, get rid of some of the hydrogen peroxide. One other interesting piece of data is 8-isoprostane. This is a biomarker of oxidative stress and inflammation in the cell. And from our study, we were looking at the dust increasing 8-isoprostane, and it, of course, did. There are issues where 8-isoprostane is indicative of asthma. So there are papers in literature that show that 8-isoprostane is usually going to be higher, or there are elevated levels in people with interstitial lung diseases and asthma, COPD, and so forth. So now we're going to open it up for questions and discussion. Hopefully I didn't go too fast, but I know our time is ticking.
That's great. Thank you, Dr. Gerald. Are there questions? We had a couple in the chat. Maybe I'll kick off with those. One question is that can standard masks shield workers from inhaling the dust?
So that's a great question. And I'll preface that by saying, when I was a doctoral student, I never wore my mask to go collect dust. And I hate to be like this, but I guess thinking about the community and the people that are working in those industries, they don't like to wear masks. And I say that to say there are masks, and masks are very helpful against some of the particulate matter, some of the dust and gases and things like that accumulate. But if we can't get the people to wear the mask, then they're not effective, which I guess everybody understands that now with COVID, right? Everybody's telling you have to reiterate, wear your mask, wear your mask. And so there are masks. There definitely are masks. I was told to wear my mask. I was hard-headed as a student. And one of the big things is it's really hot a lot of times, especially here in southeastern North Carolina. Iowa and Minnesota are the first and third hog producing states in the country. We're the second, but they don't have the temperature issue that we have here. And so I think one of the bigger questions might be, how do we make sure people wear masks in those types of facilities? But there are masks, and there are definitely masks that, would help to provide protection. Definitely.
Right. I think that's a good point. I know I worked way back after 9/11, and one of the big issues with firefighters as well is wearing a mask under hot conditions. And these people are working pretty hard. So there's increased resistance to breathing, which makes it more difficult. But you're absolutely right. It's one of those things that sometimes you don't appreciate, what safety now for safety later.
Yes.
But, let's see, another question here. What areas were you sampling the dust? And as somebody pointed out, I thought the micrographs were rather nicely presented. But where were you sampling, and how far from the facility did these dust travel, or are these just local to the immediate environment?
That's a perfect question. So most of these studies, and there were data from different studies. And so some of the work was done in Nebraska. And so those facilities, they were collected, the dust was collected in Nebraska or in Iowa hog barns. And so they were collected basically inside the hog facility. So go in and you just start brushing it off into collection vesicles. The same for most of the work that I showed you. There was some characterization work. The same kind of thing happened with those samples. Basically, you go inside. I have a makeup brush, and I basically just sweep off the dust off into collection vesicles. and take it back to the lab. So all of the dust work that I showed here today was collected inside a facility. As far as the question, I guess, is how far the dust can travel.
Yeah, I guess one of the questions is whether you, and maybe you didn't sample any aerometric kinds of sampling procedures, or maybe that's sort of in your plan or however.
Yes, so I have not collected dust from surrounding communities. However, I am actually doing something similar to that right now. So I'm in the process of looking at how to collect dust from homes and things like that, of course, because there are issues with antibiotic resistant strains of bacteria being found in the nasal carriages of people that live near the communities. And so there's a huge, I guess you could say, a huge part of it that, you know, hey, we know that it's in the facility, but how far is it going? And so I am working on something like that, but I have not done it yet. So I'll just clarify that I have not done it yet. But there are studies where they have looked at how far the dust particles travel and things like that. But they can travel very far, to be honest. I know they can.
And you may or may not be able to address this question. Maybe there's someone on here. To what extent is the state working to protect the residents from some of these pollutant emissions? And as we know that, well, you know how that goes. It's a big industry. They're powerful. The legislature is pretty much in the, I hate to say in the pocket, but there's a certain amount of that going on. And I do know, just some work that I was associated with, that with the spraying sometimes of the waste material, et cetera, there's a lot of residential air distribution. And there was one area in Duplin County where my wife was doing some work that within, land is cheap to build the school. So they had a high school, middle school, elementary school on sort of one large campus. And within less than 2 mile radius, there were 12 KFOs.
Wow.
And at recess, the kids couldn't play outside. So that kind of speaks to that issue to some extent. And you may have more to add to that, I don't know.
Yes. I actually had a grad student back in 2016. He conducted some GIS work that he looked at elementary schools in close proximity to KFOs. So that was actually, he made some maps and presented it at a small conference. But yes, definitely, I think it's hard to say a lot about the issues, because I think agriculture is so big here in North Carolina. It's a part of an economy that drives everything, and it's agriculture. It's how we feed people. The slides that I usually actually present, there's actually a slide, and I said, you know, it's agriculture. It's imperative to the world. This is how we eat. So it's really difficult to say you can't do this or can't do that. It's figuring out how we can be more sustainable. But right now, I hate to say it, it's almost like a necessary evil, because, you know, we complain about the food prices, but we of course don't want to spend so much money on the food, but we want these things. And so there's a lot of issues, and it's very complex when you start trying to.
There are a number of advocacy groups, including Clean Air Carolina, Search, and some of the other equal justice group, environmental justice groups that are working hard to try to push back on this a little bit. There are ways to do things, I hate to say sustainably, but certainly closer to that,
right,
to that goal, and it's important. And this meeting is part of that, trying to activate people to actually step up and make a difference in that regard. Someone was asking about the availability of the papers that you published on your ROS and that sort of thing. I don't know, maybe somehow through our linkages we could get those out there so folks who are listening could get that if they want to look at your work. If there are other questions out there.
Yes, if you probably go to Google Scholar and put my name in, they should pop up if you're you know, just itching to get to them. But yes, I definitely can disseminate them.
And someone else asked, who is measuring the long-term cost of such behaviors in terms of, I mean, those are all issues. I mean, you actually mentioned some of that. Life expectancy is less. among many of these people, and that's certainly a major index of overall health status in these communities. I mean, there are many factors contributing, of course, but that's what these people, a lot of these folks are doing. And you know, there are issues with COVID outbreaks in some of these facilities, both here and out in Nebraska, actually. So, yeah, it's a complex issue, no question about it. Any other questions anybody wants to? You can get unmuted, I suppose, if you want to speak up, or you can just type them in. Well, if not, we're close to the end, I guess. Where are we?
Yes, at 4:25, there should be, well, just now in a couple of minutes, there should be closing statements. So if you'd like to use Whova to get over to that space, it should be in agenda, and then followed by closing statements, I believe is the title. Okay,
well, I'll leave it to you, Dr. Gerald, to give us some thoughts and parting messages.
Well, I thank everyone for coming to the talk today. Hopefully you all, of course, are, you know, geared up, fired up to try to make a change. I definitely try to do that to my students. I tell my students that all the time. Individuals matter. So all it takes is one person and spark an interest and ignite somebody else, and we can make a change. There are advocacy groups like Dr. Costa mentioned that, of course, can push forward and try to, you know, there's a lot of litigation too with the hog farms and with agricultural farms and things like that. And so, you know, I think we can do it. Hopefully we can. I have faith in you guys.
Great. Well, thank you very much, Dr. Gerald. Thank you, Maria, for sort of making sure that things work for us. And I appreciate folks coming to the session, and you have the contact information if you want to pursue more with Dr. Gerald. Have a good rest of the meeting. Bye-bye.